Okay, we get it. Hi there. Hope you enjoyed that introductory segment. Some people may even call it revolutionary. uh, anyway, you're here to find the volume of the region between f of x and the line y equals 0 from 0 to 4. Well, it's a pretty easy procedure as long as you know that formula right there. V is equal to pi times the integral from a to b of r of x squared dx. We like to call this the disk method. Let's see what it looks like in practice. We're going to find r of x first. So zooming in here, we're just going to take a random slice anywhere from 0 to 4, and we're going to call it r of x. It's also important to keep in mind the coordinates at this point are x comma the square root of x, illustrating that this is just a random point anywhere between 0 and 4. Now, all of this is just to say that r of x in this situation is the same as f of x, which means that r of x actually equals the square root of x. But we have to remember that our formula isn't asking for just r, it's asking for r squared. So what happens when you square a square root? I think we know that one. That means r of x squared is equal to just x. And now it just becomes a matter of plugging into the formula, which means v is equal to pi times the integral from 0 to 4 of x dx. Taking the antiderivative, we're going to get equals pi times 1/2 x squared, the antiderivative of x, from 0 to 4. Continuing on, we're going to get equals pi times 4 squared is 16 divided by 2, that's 8. 0 squared times 1/2 is 0, which means our final answer is 8 pi. Isn't that neat?